Good afternoon, colleagues. Let's go on to talk about Python programming language. And today, I think that it makes sense to tell a few words about str data type. Str data type actually it's a type which is used to represent string data. Let's see how we can use it and what operations can be applied to it. Actually, uh, what can be some other options of using strings. In Python, if you want to use strings, you can use double quotes or single quotes. We can see that in both cases we have the same data type, and the name of this data type is str. It's a double quotes, then we can also use single quotes. Both of them have the same meaning, and we can just choose maybe the most appropriate type of quotes. Usually we do that. For example, we can use single quotes if we have double quotes inside of our string, or maybe in opposite way. For example, we can use single quotes inside of double quotes, something like say. And now I need to use double quotes, so this is the reason why I use single quotes around the string, something like that. Also, it's possible to use escape sequences in Python. You know that Python is written in C, and there are a lot of syntax constructions and some syntax ideas I inherited from C. For example, we can use maybe something like multi-line string, and if I want to introduce a new physical line between these two words, I can use /n character. So this /n character is actually used as a new line character, and in this case you can see that now we have two physical lines. Sometimes there are a lot of different possible characters can be used with slash, with backslash, and all of these characters can represent some different escaping sequences. You can just take a look at documentation and see what particular characters can be used. But sometimes we can have some problems with that. Let me show you an example. Yes, to see how actually these escaping characters work, we can just print a character using print function. So suppose we have a path. For example, unfortunately, we should use Windows, yes, Windows operation system, and we want to provide the path to some particular file. You know that in Windows we use usually backslash to as a delimiter between the some parts of the path. So it can be a directory with name new. Then, for example, we have file with name file. How this string really will be represented in a memory. You can see that result can be something like that, because /n means new line character, /f also have some additional meaning, and so on. And actually it can be a problem, because later it's sometimes you can have an error because you use incorrect path, or even sometimes it can work, but as a result your data will be stored in some other place where you actually don't wait for storing your data. So in such cases you need to find the place where data is stored. So to avoid this problem, we can do two different things. For the first, we can just use double slashes, and in this case each slash means say something like escaping character, and this slash tells that the next slash just a regular slash. Another case, another way how we can do the same, it's just using of our row strings literal. R means our letter before string means that this is a row string, and actually in this case we just tell interpreter that we don't want to read the slash as escaping character. We call this row strings. Actually, this hash character is used for to create comments. So in this case, it's going to be one-line comment. Also, sometimes we want to declare some strings which can contain more than one physical lines, and for these cases we also can use something which we call a multi-line strings syntax. To define multi-line string, we can use 3 quotes. It can be again double quotes or single quotes, it doesn't matter, and then we can use just multi-line string, just use new line character inside. You can see that now your string is created. So this is a different ways to represent string constants in Python, and in different cases we can use different representation. For example, row strings can be useful for paths in on Windows operation system, or for example to represent regular expressions. What about multi-line characters? Sometimes they can be useful for creation some prompts for user for some messages which we're going to print, or for example multi-line strings can be used as comments in our code. Actually, why we can use them as comments? Usually, when we write our programs, Python just ignores any constants. Let me show you an example. I can create just a program. Yes, it's going to be a new text file which I can store with some particular name, for example hello.py, and here I can use some comments. It can be a one-line comment, or maybe let's print something here to see that really our program works. For example, hello world as usual, yes. And also, if I just use some constants inside of my program, for example 1, 2, 3, then Python interpreter just understands this value as expression. Let's just run the code. Python 3 hello. I'm sorry, I should go to my root folder. So Python 3 hello.py. You can see that in this case we just print hello world. What about this expression? Python just ignores it because we don't tell it to do anything with this expression. So any constant which which we can write inside of our program will be just ignored by interpreter. Also, we can use multi-line strings here, and because Python ignores them, we can consider them as multi-line commands. It can be 3 double quotes or maybe 3 single quotes, it doesn't matter again. So we can again run this program again and see that again Python ignores this message. So in Python, Python doesn't have, Python language doesn't have some specific syntax for multi-line comments, but we can use multi-line strings as multi-line comments if we don't store them in any particular places. Let's go on, and then let's see what operations we can use with strings. For the first string, we can check the length of the string using built-in length function. You can see that 8 characters are used here. We can use in operator. We can write something like food in football, and in this case this is just an expression, Boolean expression, which returns true if the first operand it's just a part of the second operand. By the way, if we want to invert the result of this expression, we can write something like not food in football, but also there is a additional construction which just is used to make our code a little bit more readable. It's additional operator, by the way. It's developers of language think a lot about how to make the language more readable, and they sometimes introduce some specific operators or statements or something like that, which can be used just to improve readability of the code. So in this case, we can write instead of not food in football, we can write something like not in football. So this construction, we can say, more readable and maybe more more correct for English language, for natural language. So this is the reason why this construction is used in a language. Then what we also can do with strings, we can add strings. We can use concatenation. So 2 strings are connected one to another. Also, we can multiply string by integer, something like that. It can be useful for aligning some strings in some messages which we are going to print or something like that. For example, we can create delimiters, something like this, lines which can be used to separate some parts of our output and so on. So this is a multiplication strings by integers. Also, we can extract characters from our string using indexes. We can write something like football. Maybe I'm going to copy this string for future using, and then we can extract, for example, a character with number 0, which is the first character. By the way, strings are immutable. It means that we can't change the state of our string. If I try to assign something to my string, Python raises an error and says that str doesn't support item assignment. Str object doesn't support item assignment, so it means that strings are immutable. It's not possible to change the state of the string. Then also we can use negative indexes. What it means, for example, I can write something like -3 as an index. And what it means, actually, negative indexes are used from the end of the string. So this character has index -1, then this character has index -2, and this character has index -3. So if we want to extract, for example, last character or maybe last but one character, you can just use negative indexes for that. Also, Python supports slices. This is a operation which allows us to extract substring from a string. Yes, maybe almost of all programming languages allows to do the same, but in Python we can do this with using of very simple syntax. Let me show you how, for example, we can extract first part of our string from maybe character number 0 to character number 3. We can just write something like 0 colon 3 colon maybe 4. This is a general rule in Python. In all ranges, usually the first index is included to a range, the last index is excluded. So it means that we take characters with index 0, 1, 2, 3, and that's all. Characters with index 4 is excluded. And you can see what is going to be the result. By the way, if I want just to extract something from the beginning of the string, I can just use a colon without specifying the first index. Yes, Python understands that we can do that. We can just extract something from the beginning of the string, and the same thing we can do to the end of the string. So this is a string from letter number 4 to the end of the string. Again, it's convenient if you compare this syntax with other languages, for example with Java or C++ or something like that. In such languages you need to find the length of the string, then call some function like substring and so on. So you will need to write to type maybe something like I don't know, 30 or 40 characters to do this things, but in Python we can do this in a very short way. Also, it's possible to make a copy of the string using such slice. It means that we just take a string from the beginning to the end. And also we can use negative indexes in slices. I can write something like 2 minus 2, and this part of the string is going to be extracted. How it works? We find character number 2, which is O, and then we go to character with number -2, which is L, but the last character is excluded, so we have this part of the string as a result. Then also we can provide the step which we want to use to go through the string. How we can do that? For example, I want to make a copy of the string, but also I provide the third argument, for example as 2. I also can write some index before the first colon, some index between first and the second colon, and also I can provide the step. So this step tells that we want to extract characters from the beginning. Actually, it's going to be OF, then F, 0 plus 2 this character, 0 plus 2 this character, and then this character. And you can see the result here. Or it's also possible to use negative steps, and actually this is a idiomatic way to reverse strings in Python. So if you want to reverse string, we can just use such type of slices. Yes, again, we can also extract substring here, and then we can say that we want to go from the end to the beginning. Maybe this is almost of all the most useful constructions which can be used with strings in Python. Later we are going to return to strings, and also I'm going to show you some other constructions which also can be useful, but for now maybe let's go on. And maybe we discussed almost of all main data types which can be used in all our programs. Maybe which are used in almost of all programs. Yes, the most popular data types we discussed for numeric types on our previous lecture, and today we considered strings. Now let's go on, and now maybe it makes sense to tell a few words about statements. Later we are going to continue to talk about data types, because we also have container types like lists, maps, dictionaries, sorry, lists, dictionaries, tuples, and so on. So later we will see how to combine our items together in one, a lot of items together in one data structure, and then how to use it. So for now, let's tell a few words about statements, how we can write our Python programs with our statements we need to use, we can use, and maybe let's start with assignment statement. Actually, Python is dynamic language. You remember that, I hope, and dynamic language doesn't require to declare variables, and as a result, Python doesn't have any constructions to declare variables. Instead of that, we can just assign value to variable, and in such way we can introduce new variable in our global scope, and also provide the value for this variable. Now you can see that we have new variable a, which contains 1. By the way, in this case, if I want to print the state of this variable, I can just write it, I can just use it in my shell and then run this cell. So you can see that the value of a is printed. I can't do the same in a program here. Yes, here if I write something like a equals 1, then a, as a result my program will just not print anything, because again, this is just an expression. Python calculates the value of this expression and doesn't do anything with it. If we want to print the result, we should use print function. Let's run it again, and now you can see that result is printed. So in programs, if we want to see the content of the variable, we should use something like print function. There are some other ways to do that, but print function is the most common way. In a shell, we can just use expression and see the content of the variable or something like that. Let me tell a few words about these identifiers. What are rules for identifiers in Python? What letters or what characters can be used in identifiers? And actually, here we have almost the same rules like in other languages. So in Python, variable name can contain Latin lowercase letters, uppercase letters, digits, and underscores, and also identifier can start with digit. Yes, so maybe A1. This is the correct name, but 1A is incorrect identifier. Like in other languages, so we have the same rules. If your variable contains more than one words, sorry, we can separate these words with underscore, something like my var equals to example. And actually, this is a naming convention which is described in PAP 8, so the most correct way to define variables. We even have some specific name for that. We call it snake case. You know, we have camel case when we start each word from in identifier with uppercase letters. If we use underscore, we call this snake case, because Python is a snake, yes. So just a naming convention, but you know, you remember naming conventions are important for developers, because they simplify the process of reading code and using code, working with code. Also, so we use lowercase letters. We don't use uppercase letters in variable names. And also what I want to say, now in Python 3 we can use Unicode characters in variable names, but maybe it's not a good idea to use them, because in different alphabets we can see characters with the same glyphs, so it will be very difficult to understand what particular alphabet is used for some particular variable. So it will be better to always use only Latin letters in Latin letters, digits, and underscores in variable names. In this case, we declared variable a with value 1, and actually we can check the type of this value using type function as usual, but we should know that in this case it doesn't work in the same way like in other languages. So in Python, variable doesn't have a type. Only object which is assigned to this variable has a type. So I can write later something like a equals abc, and now type of a is going to be str. So variable just something like a reference to object, and object has a type. Variable doesn't have a type, and it can be used to store values of different types. Sorry, please. There are at least 4 different types of assignment statements in modern Python, and let's consider all of them. For the first, we can assign some particular value to more than one variables. It can be done in such way. So now all our values all our variables contain value 0. Yes, a equals 0, b equals 0, and so on. It can be convenient to just to assign more than one value, to more than one variables. Also, we have a short notation for arithmetic operators. For example, if I want to do something like a equals a plus 1, I can rewrite the same code like a plus equals 1. So both lines are the same lines of code. And this construction can be used with all possible arithmetic operators. I can write something like a divided equals a slash equals 2, and we can see that now result is 1. Why 1? Because we had 0 in a, then we added 2 ones to the value of a, and then divided 2 by 2, so result is 1. The same syntax is used in C language and other C-like languages, so I think that it's not maybe unusual way to do such things. But what is interesting here, in Python we can't use something which we call post-increment or pre-increment operators like in C. The reason is that Python is an interpreting language, and actually it should just make one path through the code to understand code and to execute it. And these operators actually it's not possible to parse or all possible combinations of these operators using only one path. So Python doesn't allow to do that. Also, the third example of using an assignment statement, it's an assignment statement which returns a value. This actually it's a new syntax which was introduced in Python 3.8. So before Python 3.8, we couldn't use this construction. So usually a regular Python assignment statement doesn't return a value. But in Python 3.8, new syntax construction was introduced, and we can write something like a, for example, colon equals 1. Sorry, please. And this construction not only assigns 1 to A, but also returns value 1 as a result. We should use parentheses here, but usually we use this construction as a condition in if statement or branching statement in loop statements, and in such cases we don't need these parentheses. Sorry, please, colleagues. There are some cases where this construction can be useful, and later I think that we will see some examples when we will start to work with files or databases. We will see where this construction will be convenient. Also, in assignment statement, we can use unpacking. Unpacking usually is used for collection data types. And for now, we don't know about collections, but we know about strings. And strings also are collections because they contain some characters, yes, and as a result, string can be considered as collection data type. So I can write something like A, comma B, comma C, for example, equals, and some sequence of characters Q, W, E. Now, if we take a look at A, we will see that it contains Q, B contains W, and so on. C will contain E. Let's check to see that it really works in such way. So our string is unpacked to these 3 variables. And sometimes it can be convenient. Later we will see that the same approach can be used for all possible iterable objects, all objects for which we can use iterator protocol and extract some set of items. We call this unpacking, and it is really convenient. There are a lot of cases where we can use it. And it really allows us to make our code more readable. So maybe that's all about assignment statement. You can see that Python in this case has a very simple syntax, and in general we can say that this basic Python syntax, all basic statements in Python are very simple, and it's easy to understand them. Then the next statement, which maybe it makes sense to consider, it's if statement or branching statement. This statement is used to check some particular condition and then make a decision what particular branch of code should be executed. Let's write an example. So suppose A equals 1, B equals 2, and we can write something like if A less than B, then we can just write something like result equals A and then print A. Otherwise, we can use else, then result equals B and print B. Now, maybe it makes sense to discuss the syntax. You can see that this syntax is a little bit unusual, and in Python we usually write such statements in a little bit different way, not the same way as we do that in other languages. For the first, you can see that if keyword is used as in other languages, then what about condition? In this case, we don't need don't need any parenthesis around this condition. So when we don't use parentheses like in our other languages like C, it just makes our code less noisy, I can say. Then after condition we always type a colon, and this colon means that later in the next lines we will have some block of code. How to say interpreter that these two statements are going to be just a part of one particular block of code. To do that, we use this indentation. So instead of using something like braces like in C, or maybe some keywords like begin or and like in other languages, instead of that in Python we just use these indentations. And all statements in the same branch should have the same indentations, the same indentation level. It's important, so Python always checks that a number of spaces in all lines is the same, and only in such case our code will work correctly. Then we have else branch, and again else should be in the same level of indentation as our if. So this is just parts of the same level of logic. We have colon again, and always after the colon we have an indentations. So this is a main idea how in Python we use any constructions which require blocks of code. So it's not actually it is not a problem for us when we write a code to make these indentations. Usually, if we do the same in other languages, we also use indentations to make our code more readable. Yes, so in C, in Java, in C++, when we want to say that some part of code, so it's just a set of statements in the same block, we also use these indentations. But in other languages, these indentations don't matter on how our code works. But in Python, indentations are important, and they actually they are used to define blocks. Sometimes someone can ask what should be this indentation. It can be tab, tab character, or maybe space, or maybe how many spaces or tabs can be here. For the interpreter, it doesn't matter. Interpreter just wants that all indentations on the same level should be the same, should be consistent. So if here I use for characters in the next line, for 4 spaces in the next line, I also should use 4 spaces. If I use 2 spaces, so it is okay, but in the next line I also should use 2 spaces, and so on. But what about conventions? In PEP8 you can find that that we can't use tabs for indentation, and also always one indentation should be 4 spaces. It's just a convention, but usually we follow these rules, and in all Python code we have 4 spaces as indentation. It's not difficult to do, actually. It's not difficult to always use 4 spaces for such cases. You can just set your text editor to insert for 4 spaces for such instead of tabs, and that's all. So this is a basic branching construction in a Python. Of course, in this case, I can write the same logic in only one line. I can just I'm sorry. I wanted to write here something like result, print result, and here also just a result. It will work in the same way. I just did that to explain how to write more than one line of code in the same block. Let's consider another example. Let's also check our A and B for equality. So, for example, I have the same conditional statement, and then I want to check that if A equals B, then I can print that they are equal. And please know that now we have two indentations here. Yes. Before that we had one indentation level, but because we have two columns, the first column, then we have the second column, so we have also two indentation levels here. Then we can again write else and move this part to the right. So now it works in such way. If we, for example, use the same values for A and B, you can see that our code prints they are equal. But sometimes this construction can be inconvenient. What I mean? For example, we want to check a lot of conditions. For example, our A value can be equal to a lot of different constants, for example, 1, 2, 3, and so on. And as a result, we can have a lot of checks and a lot of conditions, and all of them will create very large number of indentations for last lines. To avoid this problem, actually, in code formatting, we can use another statement which has name elif, or maybe it just stands for else if. So I can write something like that. So if A less than B, then result equals A. Otherwise, else if A equals B, then we want to print they are equal. Now I can, I can move all of these parts on the previous level of indentation and make my code more concise and maybe a little bit more understandable, because we can exactly say that only one branch will be executed here. What about elif? We can use more than one elifs in the same if statement. So we have if, then we can write a lot of elifs, and also after that we can use only one else. So this is examples of branching statements in Python. Also, there's another question about switch statement. Maybe you know, in C, for example, or in Java, or in other languages like C or Java, we have usually a switch statement which allows us to check more than maybe one condition and the same expression, and then we can perform different actions depending on this condition. What about Python? Before current version of Python, we can't use we couldn't use switch statements. So in Python, before version 3.10, we usually used only if and elif statements for such cases, and actually it was enough for almost all cases. But in latest version of Python, in version 3.10, new syntax construction was introduced. This new syntax construction has name structural pattern matching, and it has a significant difference between actually we can say that it's not just a switch statement. It has it's significantly more powerful, and later we will see some other examples of using a structural pattern matching later when we will discuss different containers. We will see how we can use them in pattern matching statements. But for now we don't know about containers, so I'm going just to show you the simplest way to use structural pattern matching just for the cases when we want to use them as switch. So I can write something like maybe A equals 1, then I can write match A. You can see that now we even just don't have syntax highlight because Notebook for now doesn't support this. That doesn't know just about this statement because this is a very, very new version of Python. Then we can write something like case, for example 1, and we can print 1. Otherwise, we can write case 2 and print 2. Then for all other cases, we can write case underscore, which means something like default in C. So with this branch we're going to execute if our A value doesn't contain 1 or 2. So we can write something like many. Let's see. Now A equals 1, so our code prints 1. If we change it to 2, then result is going to be 2. If we change it to 3, 4, or something like that, any other values, we can see many. So it looks almost in the same way as in switch statement, but as I said, this construction is significantly more powerful than regular switch in other languages, and later we will see the difference. We will see how also this construction can be used. So this is a match statement, and the next statement which we are going to discuss, it's actually exception handling statement. We can also consider exception handling as I think something like branching, yes, because in this case we have also some particular condition and we want to check this condition, and depending on this condition we want to do different things. What are exceptions? Actually, exception it's something like an error, but it's not a syntax error like maybe just an error in our code. Instead of that, it's something like runtime error. So this is the case when we have, for example, incorrect data or some incorrect resources, incorrect state of resources, and we try to work with such resources, and in runtime we can see that we have problems with our data. So in this case, in such cases, Python raises exceptions, and if we want, we can catch these errors and these exceptions and provide some way to fix the problem and continue execution. Let me show you some examples. We'll see how exception work and how exceptions work and how we can use them. For example, if we divide 5 by 0, we can see an error, and actually this error has a name. Name is zero division error, and actually this is the name of exception which is raised in this case. Another example, if I try to use incorrect index for my string, in this case Python raises index error. If I try to change that to convert data types, by the way, we maybe didn't discuss before explicit type conversions. Let me show you how it works. It's easy to do. By the way, if I want to convert one data type to another, I can just use type name as a function. For example, if I want to convert string to str, I can just call str as a function, and as a result, we can see the string. We can do this in opposite way. So I want to have an integer. So 1, 2, 3. And now it's integer. And any other types can be used in the same way. Sometimes it's not possible to make such conversions, but if it's possible, we will have just a result of some other types. what is interesting, maybe actually it's interesting how we can use conversion to bool. Actually anything can be converted to bool. What about integers? 0 is converted to false. All other integers are going to be converted to true. What about collections or other data types? If we convert empty collection, for example empty string, result is going to be false. If we convert string which contains something, even if it contains a space, result is going to be true. So here is an empty string, and here we have string which contains one space. So actually we use it very often to check strings for if it's empty or not. Strings and other collections in the same way. So suppose we have a string, something like as, which is empty, and then I can check if not as, then we can print string is empty. Actually, this is a idiomatic way to check if our string is empty, and even you can find this construction in PEP 8. So this is the most correct way to check if our string is empty. String or other containers also. So if we try to convert, for example, string which is not convertible to integer, in this case we have value error exception, and so on. So you can see that there are a lot of types of exceptions in Python for almost all possible different cases. We can find different exceptions in the language, and how to catch these exceptions. So for example, I have a variable a, and then I want to calculate the value of variable b, which is going to be something like 5 divided by a. And I know that a can be 0, so I can wrap this expression, which potentially can raise an error. I can wrap it in try block. This try block tells interpreter that it's possible to have some exceptions, some problems in this part of code. Potentially it's possible to have problems, and then we can provide except block. Of course, the same way as in if, we can write here more than one lines of code. Then we can write except, and then we can print something like maybe error for such case. And you can see how it works. If we consider this case, when interpreter tries to divide something by 0, it raises an exception, then our code is going to be interrupted, and we will see this trace back, which tells us that we have some problems in the code. In such case, Python interpreter usually tries to execute this code. Then if we have an exception, because it is in a try block, it goes to except branch and fix the problem. We should provide some code which can fix the problem, and then our program continues execution. It will not be interrupted in such case, and as a result we can handle runtime errors and provide maybe some ways to recover our program after any problems. Maybe you can say that maybe if you have some experience with other languages like C++ or Java, you can say that maybe such approach is not correct, because we have something which we call exception-based logic. And for almost all modern languages, we consider exception-based logic as a little bit incorrect approach. The reason is that in such languages like Java or C++, when we use exceptions, when we use try and catch statements, in such cases, our compiler requires some additional resources for saving stack and so on. And usually we say that just that using try catch blocks is inefficient. So in cases when we can check something using if, we usually don't use try. But in Python, we have some a little bit different different behavior. Python is interpreter, so it doesn't require any additional resources for storing stack, and as a result, try statement is cheap. It doesn't require some additional resources for doing that. So as a result, Python just doesn't require some additional resources for that, and as a reason we use try except blocks in Python very often. We even have some rule, something like either ask forgiveness than permission, which tells us that usually we just try to do something, and it's easier for us to ask forgiveness in accept than, for example, write some if statement to check to ask permission for doing that. So in Python we use exceptions or try to accept blocks significantly more often than in other languages. Maybe on the next lecture I'm going to tell you more about exceptions. We will see some examples of using them. Maybe some correct way to write try accept blocks and so on. But for now, maybe that's enough for today. Thank you for your attention, colleagues, and goodbye. See you next time.